G'day. In this series of videos, we're doing auditory psychophysics experiments using Psychopy and Python. We're building things from scratch. And if you haven't seen a couple of videos before this, I think there's 3 videos before this video, stop this video, have a look at the first couple because that gives you a lot of the background and the approach that we've made up until this point. What we have at this point is a very skeleton program that will cycle through the number of times that you want to do for the trial, and it will collect input from the keyboard and then go through the next trial. We're not playing any sounds yet, we're not controlling any of the times or anything like that, we're not saving any files. What we're going to do in this video is start to introduce the timing. All we've done up until now is literally just waited until the user pushed the F or the J button, or the Q button if they wanted to quit out. What we have to do now is introduce some timers using the core.get and we're going to essentially pause the execution of our program until we satisfy some of these times. What times do we have to be aware of? Well, let's go back to the experiment that we're mimicking here. So this is figure 1 from Michael's paper. And what they've got here is a very helpful overview. They've got it in the text, but they've also got it here. Can you see that? You can. Let me just zoom in a little bit more. Where what they've done is they've said, okay, when the user starts a trial, they're going to have to wait for 1 second. At the end of that 1 second, if the experiment calls for a Q, it will play the Q for 250 milliseconds. The numbers are down here. At the end of that Q, if it's present, the program will wait for 500 milliseconds, and then it will either play the probe or the target sound in either the first 250 millisecond window, shown here, or the second 250 millisecond window. Each of these two are separated by 250 milliseconds. At the conclusion of this second window, which may or may not contain the sound, Michael then waits another 250 milliseconds, and then on the screen a prompt was then displayed to the user to say, please respond now, or response. And then once the user responded, it would then cycle back. That's what this dotted line here shows. It then reinitiates the sequence to then wait for that 100 milliseconds again. So what I've done is I've created a little table here myself, because I have to keep track of the times and the delays essentially. So I count 7 delays here. Each of them have different positions inside each trial. Now we're going to use the same general approach, sorry for the noise, we're going to use the same general approach to basically count down for each of these times. And we're going to use core.get. Let's have a look here. So we've started the experiment and we've generated some text. We've then created the window and the text stim, and then I've got a win0.flip there. What we're going to do right at the start is we're going to tell the user to press space to begin. So this is before we even get into the program. We're just going to run it, and then we can leave the room, like if we were actually running the experiment, leave the room, and then the subject will put the headphones on and then read the screen and goes, oh, okay, press spacebar to begin. So we'll do that in our own experiment. So we'll do this before we even get into the main loop of our experiment. So what we can do is we can go text stim .set text, and we want to set text to the begin text. What we want to do as well, I think this might be a little bit too big to fit on our window, so let's just drop the height down a little bit. So we'll do something like text stim.set height, and we'll set this down to say 24, and then we can draw it to our window. So text stim.draw, and then win0.flip. Right. Now, what we want to do is do nothing until
our subject presses the space bar. So the way that we're going to do that is to set up our wait key. So event.wait keys. And remember, we want to put a list of keys in that we're looking for. So we'll go key list, and I'm just copying this from down here, what we had before. Key list equals, and we are only looking for the space bar. And what else do we want? We want to clear events as well. So if space in key. Well, actually, no, we can probably get away with nothing here. We're just looking for anything, really, aren't we? Let's just see what happens. We'll clear the screen here. So this should hopefully show press space to begin. Okay, no thing set height. Spelt set height wrong. So let's go over here. So you can put a conditional statement after your wait keys if you want to split the execution of your program according. What we're doing is we're just basically saying, just wait until any key is pressed. So we'll hit the space key here. Okay, and it's done its thing. So that was a little bit too big. So let's make this window just a little bit wider. So this is the X number of pixels in the X direction. The second number that we have here is the number of pixels in the Y direction. So we'll go to say 500, should be okay. So it's going to wait, excuse me. And then what we're going to do is once we've gone into our main loop of the program, we no longer want to present to the user, press space to begin, we want to clear the screen. The way that we're going to do that is we're going to set the text stim, the string, to nothing. So text stim dot set text. The other thing that we could do is probably do a win0.flip without first drawing text. So that's another way that we could probably get around that. We'll set an empty string there, text stim.draw, and then win0.flip. Let's see what happens. Psychometric.py. So again, we should see a slightly wider window now, and it should say press spacebar to begin. So we'll hit enter there, we'll start the program. What do we see? Let's press space begin, so it looks, we can see what's going on now. We'll push the spacebar now. Okay, and now we're starting. Now if I hit F, you can see on the command prompt we're now into the program that we had before. I just hit J then. F, J. I'm hitting T, nothing. I'm hitting G, nothing. And then we go through the experiment. So what we've done now is we've set the lead in to the experiment. So if we go back to the figure, we are currently outside in this spot out here before we start the main loop. So the user can now control the main loop, or can now control entry into the main loop. So let's go back. So what we need to do now is we're now at this point here. We now need to wait 1000 milliseconds. 1 second. So let's call that, Michael in his paper calls this the initial phase. So this is, I've just taken it through here. So in that text there. So we'll call this initial. And what I'm going to do is I'm in the habit of setting up here a set of variables. Okay, so we're going to set up the timer durations. Because what I'm going to do later on is if we put this into a GUI, what we can do by doing it this way is later on we can set, using the GUI, the individual intervals, and we don't have to go into the actual code itself, you know, the bare bones stuff, to set things and find out where it was. So we're going to set up some initial variables at the moment in here, which we can then set later. So we're going to call this, let's call this initial time. No, let's call this initial wait. So we'll call these waits. And that equals 1 second. So what we're going to do now, once they've gone into the main loop, we've reset the screen, we're then going to say current time
equals core.getTime. And what this does is this will return a time from when I think Psychopy was started. Let's have a look. Core.getTime, core.getTime, Psychopy. So get time. Okay, so it gets the current time since Psychopy core was loaded. Okay, so this should work in Windows machines. So I just realized you guys can't read that because I've got it over here. Sorry about that. So here, core.getTime, get time, gets the current time since Psychopy was loaded. Sorry about that. Let's pull this back up. We'll put that back on top. So core.getTime. And what we want to do is we want to basically keep probing to see what the duration of time is. Well, what time is elapsed. So we'll say, actually we'll call this experiment time. Okay, it'd be important to know why we do this in a little bit. Experiment.time, and then we want current time equals, we'll get another core.getTime. Okay, but we're going to now subtract out experiment.time, because what's going to happen is it's going to subtract this core.getTime from the current core.getTime, and so therefore we've got an elapsed time here. And then what we're going to do is we're going to say, okay, while current time, okay, is less than the duration that we need to wait for. What was that? Well, that's what we set up here, initial wait. So while current time is less than initial wait, what we're going to do is we're going to print a debug statement just to say, hey, look, we're inside this part of the program. Now, when we finish this program, we're going to delete out all of these debug statements. We don't want them left in there. So anyway, we're in the initial wait time. Okay, and we'll actually print out what the current time is. So we'll do, say, 3.5f, and then we will put into that the current time. Now, this will just print out a single value, won't it? It will just print out some very small number because these are two lines executed pretty much one after the other. So what we need to do is we need to periodically get the current time, update the elapsed time. So what we can do is we can go current time equals core.getTime minus exp time. Okay. And then what we're going to do is we're going to wait. So we'll go core.wait, and we'll wait, say, 50 milliseconds. So what should happen is we should basically get the time, get the first elapsed time, and then compare the elapsed time to the amount of time that we need to wait. And then that we're going to put that inside a while loop and say, while the amount of time that's elapsed is less than our wait time, keep getting the current time, and then pausing it, keep getting the current time. And so you see, every time we go through this while loop, the elapsed time is going to get up higher and higher and higher until it is no longer less than the amount of time that we need to wait, and then it's going to break out of that loop and it's going to squirt us into the next part of the program. We've got this debug statement in here because that's going to give us a tangible output in our command prompt to say, hey, I'm working on this at the moment. So we don't need to control S that. So we'll hit psychometric. So nothing's going to happen until we hit the space bar again, remember? And then hopefully we should see it count up. So press space to begin. There we go, it's counting up on the left-hand side there. And now it's waiting for us to hit the F or the J button. So I'll hit F, and then you see we have that initial 1 second wait time. I'll hit J, and then F, and then J, and then F, and then we're done. And we've done those 5 trials. So brilliant. We have just created an elapsed timer to get us to that first second, the initial wait time. Now, in this experiment, we're not too concerned about accurate timing per se. So I think if we have a look here, it's actually weighted 1.00499 seconds. So that's what, about 5 milliseconds, about 5 milliseconds over a second. That's fine to me. If you want more exquisite timing, you may need to do a different approach to your timing, or you might just want to have your core.wait at a lower interval, but then you start to tax and bog down your CPU cycles and stuff like that. So it's a bit of an interplay now. I'm happy with 5 milliseconds. We're not after the timing. Remember, our research question was, whereabouts is the auditory threshold using a psychophysics approach? So we've got our current time and initial wait. So what's the next one? Well, in Michael's experiment, let's go back to Mike's experiment. He actually had this experiment where he would either play a Q tone, so beep, and then nothing, and then beep, or nothing, and then beep, like that. So we can put that into our experiment if we want. We can make it either play a Q or make it without a Q. We can look to see what happens to the threshold if we put a Q in or if we don't put a Q in. So shall we put a Q in? Let's leave it open, but let's put it in there anyway, just in case. So we'll put somewhere here, play a Q, not a Q. So what do we have to do? So we'll put up here Q, question mark, and we'll put equals false. We don't want a Q at the moment, so if Q equals true, so we'll play here. So if Q equals true, okay, then we'll do something like, play a Q. And that Q would be however long it is in the figure. 250 milliseconds, we can see that there. Okay. It's currently false, so it's just going to skip over that. After the Q, we then have a 500 millisecond gap. So let's go back down here. We've now got 500 milliseconds to wait before we go into our first window, our time window. So now let's get the experiment time again, equals core.getTime, and then we'll get the current time minus experiment time, and then we'll say while current time is less than, we haven't made this yet, so let's call this, what should we call this? We shall call this the pre-observation time, because remember, we've got two observation windows there, or observation intervals, so we'll call this pre-observation, and that was 500 milliseconds, wasn't it? So we'll make that 0.5. These are in seconds. So while current time is less than pre-observation, what did I call it? Pre-observation time? No, just pre-observation. I should remember that. Less than pre-observation. Okay, what we're going to do is increment our elapsed time. Right, and we're going to print debug. We're in the pre-observation time, and we're going to make this a 3.5f again. If you don't know what percent 3.5f is, there's lots of YouTube videos. It gives us the precision. We want 3 numbers in front of a decimal point, 5 numbers after a decimal point format, and so then we put into brackets here, we want current time. It's not an integer. We need to also finish that, and then we're going core.wait, and then we'll wait for another 50 milliseconds. Again, nothing's going to happen in that time until we get out of that while loop. So let's see what happens. Okay, expect time, expected an indented block. So what have I done wrong here? Line 68. Okay, if Q equals true, play a Q. So we're back here. No, that should be right. What have we got wrong? What have I done wrong? 68. Expecting an indented block. Play a Q. It's because I didn't put anything in that if conditional statement. Right, so we're going to do nothing until we hit spacebar. Spacebar, we're in that initial wait. Okay, what have I done wrong? Core.getTime. I didn't put the permission to get the time, which is the parentheses. So you're seeing a lot of errors that we're making here. Again, we don't have any problems making errors because that's how we learn. There we go. So we had the initial wait followed by the pre-observation time. And again, now we're at 0.5 seconds, 0.502. So we're sitting at what? 2 milliseconds over that. Again, that's perfectly fine. It's waiting for us to hit the keyboard. So we'll hit F, initial wait, pre-observation time, initial wait, pre-observation time, F, initial wait, pre-observation time. Good. So we're starting to build up the timing of these trials. What's the next one? So we've got our pre-wait here. So let's just drop that there. We've done this. We've got a placeholder here if we want to play a cue. We've then done this. So now what we need to do is wait 250 milliseconds to play a sound. So let us now. So at the end of this, what we need to do now is update the user on their experience, to say, okay, we're now in the first time window. So we need to text stim.set text. And what did we call the text before? We called the text 1. And then text stim.set height. And we'll make this back up to the nice, not 732, that's a bit too big. And then text stim.draw. Okay, and then win0.flip. Right, and now what we could do something like core.wait. So core.wait. And we could wait for 0.25 milliseconds. That should be fine. Let's do it a similar way to what we did before. We'll do the same approach. We'll do current time equals core.getTime. Now, it probably is beneficial to use a core.wait, but let's just run it doing it this way, see if we can get it to work. Current time, core.getTime, and then we'll do, that's experiment time, exp time, and then current time equals core.getTime minus experiment time. And then we say while current time is less than obs, so window 1, we'll say time 1, as in for the time window 1. So we have to put time 1 up here now. Where are we doing that? Initial wait, pre-observation, so time 1 equals, and that was 250 milliseconds, wasn't it? So let's make time 2 equals 250 milliseconds. And then we have into window, don't we? And that also equals 250 milliseconds. What do I mean by into window? Well, we've got time 1, which is here for 250 milliseconds. Then we've got this interval here, the inter window of 250 milliseconds. And then we've got time 2, which is 250 milliseconds. So I've just gone ahead and gone time 1, 250 milliseconds, into window, 250 milliseconds, time 2, which is 250 milliseconds. So let's have a look here. So we'll call this time 1. So now we say debug in time 1. Okay, great. Now what we can do is we can go text stim draw and then win0.flip, because what we're going to do is we're actually going to play on the screen the number 1. And this way we can definitely make sure that every time we're inside this elapsed loop, we're going to get the number 1 appear on the screen. And then once we've done that, so the other thing that we would do, okay, if our sound was actually located inside this time window, we would actually play the sound. So let's put that in as a reminder for later. Now we have to now wait core.wait, that time period between the two. So core.wait, and that is going to be the inter time. Now the reason I'm doing a core.wait here is because we don't need to do anything to the screen except for turn off that stimulus. But let's say we wanted to control a more complicated stimulus during each time point of that duration, that time window, then now we've got control over it. So that's what I'm showing you here. So into window, sorry. So into window. So into window, not into time, so that's called into window. So what we want to do now is actually turn off that text stim. So text stim dot set text. Well, that sun's a bit bright. The sun's actually out today here in Germany. It's about time. Anyway, so text stim dot draw, and then win0 dot flip. So basically what's happening is we've blanked out that text stim. This is the way that we're going to do it, so we can definitely be certain that we've turned that off. Now you have to be a bit careful because we're doing a text stim, and that can take a little bit of time to update to draw. Got to sneeze. No. Okay. So we're now waiting for that into window, so that should wait for 250 milliseconds. So let's just do a print here. Debug, waiting into window. That's not going to update for us. That's only going to give us a single printout. And so now we need the second time window. So we need to do now text stim dot set text, because we now have to update our user. We're in the second time window, so this is going to be called time. What do we call this? Text 2. We've set the height before, so the height should still be the same. And then text stim dot draw. We're not going to flip. Oh, we can flip it to the window. Win0 dot flip. And then we do experiment time equals core dot get time, and then current time equals core dot get time minus experiment time. And then what we're going to do is while current time is less than. Now what was before? Time 2. So time 2. Okay, print debug in time window 2. And then what we'll do is we'll do something like a %3.5f. We'll print out current time. Oops, we're not running Python 2 here. Like that. And we'll update the elapsed time. So that will be, we should actually call that elapsed time, shouldn't we? I might do that for the next video. And then we'll wait. Oops. Okay. And then what do we do? Well, now we're here. Can I put that there? Yep, so now we've just created the timer for this last bit here. We would also, if the sound was in this time point, we would now play the sound. Okay. So now we're here. We now need to wait the final 250 milliseconds. So what did we call that? Have we put it in there? Time 2? We haven't done that yet. So let's call this post observation. And that's 250 milliseconds as well. Okay, so, and then after that we need to put response. So we have to ask the user, please respond now. So post observation is 0.025. So we play the sound, and now we have to wait. So we have to turn that number 2 text stim off. So text stim dot set text, and again we want to control this, so we'll just set it to nothing, and then text stim dot draw, and then win0 dot flip. So that should turn it off. And now we want to wait. So we're going to call this exp time. Actually, no, we can do just a simple core.wait here. And we'll wait for 0.25 milliseconds. But what we'll do is we'll just get into the habit, just when we're first making these experiments, of putting a little debug statement in to say, hey, we're waiting for the post-obs. It's like we're in a hospital. Looking for post-ops. Post-op. So it's different. Post-op obs. Okay, so now that we're there, we now need to text stim.set text. And then we want to do the response text. So up here, we'll put in the response text. And that will be respond. Respond. Okay, put a break there. Text stim.set height. Let's make this 48. I'm not sure how big it's going to be, so let's no, we'll leave it at the same height. Should be big enough. Text stim.draw and then win0.flip. Okay, good. So this should just present to the user respond until they respond with either the F or the J or the Q. However, what we need to do now is once they've pushed that button, F or J, we need to clear the text back off the screen again. So what we need to do is text. So once they've pushed the button, we need to clear the screen. So text stim.set text, text stim.draw, and then win0.flip, because we're actually going to go back to the start of the trial. So we can do that for either of them. This should hopefully work, unless I've made a very bad mistake. So it should do nothing to start off with. Please press the space to begin. So we'll hit space. Nothing. Pre 1, 2, off. We've made a mistake here. Core, current time is core.getTime minus experimental time. We're on line 109. What a mistake have I made? Core.getTime minus exp time. Okay, exp time is not a function. So you can actually see, I think you got a bit of a hint there that it's quite a brief time window that we have to select. So we'll hit space, pre, Q, 1, 2, off. We've done it again. 1, 1, 1. Again, mistakes are okay, just as long as we figure out why we do them and we can learn from them. So hit space, 1, 2, next, off, respond, okay, F, 1, 2, wait, respond, J, 1, 2, respond, F, 1, 2, respond, F. Oh, it's not even an experiment and I'm still struggling. It's taken me back to do those damn experiments for Mike. Oh. Okay, I think that's it. I think we've got the essence of control here and timing in our main program loop. Now, a lot of this stuff here we can actually change now to just core.wait. I showed you how to generate an elapsed timer. Okay, but what we can do essentially now is for those parts of the program where we don't need to do anything, we don't need to update the screen or access anything, we can actually block, because core.wait is a blocking function. It's not going to let us access any further parts of the code. So what we're going to do is, once we've done this core stuff here, we'll do core.wait, and we want to wait for 1 second. So we'll print out here, debug, pre-Q time. I actually like doing the elapsed timer because it gives me an update of what's going on. So I might actually leave it in there. In the later program, we can probably get around it.
take it out. Respond. So if you're doing this in LabVIEW, I think it's a millisecond timer. You can put in a millisecond timer. I hit the space bar just then, that's why I didn't cycle through. Or you can get current milliseconds and do an elapsed timer like that as well. This is what we did. You can use a film strip in LabVIEW. Okay, so we've got timing now. What we have to do now, in the next video, what we're going to do is start to put in our sound stimuli, so we can actually start playing some sounds where we need them. And so we need to go back and think about, well, how can we do a non-blocking, okay, sound presentation. We'll leave this video here. Thanks for playing along. Hope you learned some stuff. We've made plenty of mistakes, but we've learned plenty of stuff as well. I'll leave this video here. I'll see you in the next one.